Given equation is 2x plus 3y is equal to sine of x. X into y plus y square is equal to tan x plus y. Therefore, only dy by dx is equal to, bring this to the denominator, sine 2x divided by sine 2y. X square plus y square plus 2xy plus x plus y plus 3 is equal to 0. Find dy by dx at 1 comma minus 1. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in the previous class, we have discussed regarding differentiation of function of a function, that is composite functions using chain rule. Now in this session, I am going to discuss regarding the differentiations of implicit functions. Implicit functions, this is very important concept. Definitely we will get one question from this, either for 2 marks or 3 marks. You will get one 3-marker question or 2-marker question from this concept. Now, what is the implicit function? So far you might have been studied explicit function. Now, functions like x square plus x plus y, functions like x square plus y plus x is equal to 2, or minus 2 is equal to 0, or x square minus y plus sine y is equal to 0, or x minus y minus pi is equal to 0, etc. They are called as implicit functions. Here it contains both the variables x as well as y. So here x square minus y plus sine y is equal to 0. This contains x minus y minus pi is equal to 0. This type of functions are called the implicit function, and differentiating such a function is called implicit derivation. That is finding the derivative of a implicit function. That is called as a derivative of implicit functions. Now the functions like x square plus y plus x minus 2 is equal to 0, or x square minus y plus sine y is equal to 0, x minus y minus pi is equal to 0, etc. These type of functions are called as a implicit function. In the last classes, we have studied explicit functions. These are implicit function. Here it contains both the variables x square plus y plus x and y. Here also x and y, and here also x and y. You cannot take let y is equal to. So how to differentiate this type of functions? Just differentiating with respect to x on both sides, and bring the terms which contains dy by dx on one side and the remaining terms on the other side, and divide. You will get dy by dx. That's all. So differentiating with respect to x on both sides, just equate the terms containing dy by dx. All coefficient of dy by dx on one side and the remaining terms on other side. So if you divide, then you will get dy by dx as the required solution. Such a type of differentiation is called implicit differentiation. Differentiation of implicit functions. Now let us consider if x minus y is equal to pi, find dy by dx. Find dy by dx if x minus y is equal to pi. So what is given here? X minus y is equal to pi. Now differentiating with respect to x, differentiate with respect to x on both sides. If you differentiate, differentiation of x is 1 minus differentiation of y is nothing but dy by dx is equal to derivative of a constant is 0, and transfer this. So dy by dx is equal to 1. So therefore dy by dx is equal to 1 is the required answer. 1 mark question, very easy. What is given? X minus y is equal to pi. Differentiating with respect to x on both sides. Differentiation of x is 1. Differentiation of y is dy by dx. And derivative of pi constant is 0. Transfer this. Minus dy by dx becomes plus dy by dx. Transfer this to the right hand side. Therefore dy by dx is equal to 1 is the required answer. Very simple problem. Now let us come to the next problem. So these type of problems are very important, either for 2 marks or 3 marks. Now find dy by dx if y plus sine y is equal to cos x. What is given? Y plus sine of y is equal to cos x. Now you cannot consider let y because already y term is given here. Now differentiating with respect to x. Differentiate with respect to x on both sides. Differentiation of y is dy by dx plus this is again function of a function. If it is x, d by dx of sin x, you can write it as cos x. Instead of x, it is y. This can be written as differentiation of sin y is cos y into differentiation of y is dy by dx is equal to, again differentiation of cos x is minus sin x, right? See here, differentiation of derivative of y is dy by dx, derivative of sin y is cos y into dy by dx is equal to derivative of cos x is minus sin x. Just you can remove dy by dx out, dy by dx, then what is left over is 1 plus cos y is equal to minus sin x. So therefore you can write dy by dx is equal to minus sin x and bring this to the denominator divided by 1 plus cos y. This is the differentiated answer. Very easy for 2 marks. See here. So y plus sin y is equal to cos x. This is the given equation. Differentiating with respect to x on both sides. Differentiation of y is dy by dx. Differentiation of sin y is cos y into derivative of y is dy by dx. Cos y dy by dx. Again differentiation of cos x is minus sin x. You can remove dy by dx out. So common factor dy by dx out. What is left over is 1 plus cos y is equal to minus sin x. Therefore dy by dx is equal to, bring this to the denominator, dy by dx is equal to minus of sin x divided by 1 plus cos y is the required solution. So dy by dx is minus sin x divided by 1 plus cos y. Now let us take a similar problem. Find dy by dx if 2x plus 3y is equal to sin x. Now what is given equation? The given equation is 2x plus 3y is equal to sin of x. Now here also differentiate with respect to x on both sides. If you differentiate with respect to x on both sides, 2 into differentiation of x is 1, 3 into derivative of y is dy by dx. We are differentiating with respect to x. This is equal to derivative of sin x is cos x. Now here this is 2 plus 3 into dy by dx is equal to cos x. And transfer this, just this 3 dy by dx as it is. 3 times dy by dx is equal to, you just keep this cos x and transfer plus 2 to the right hand side, this becomes minus 2. So 3 dy by dx is equal to cos x minus 2. Therefore dy by dx can be written as cos x minus 2 divided by 3. This is the derivative of this function. See here, 2x plus 3y is equal to sin x. 2 into differentiation of x is 1 plus 3 into derivative of y is dy by dx, and differentiation of sin x is cos x. 2 into 1 is 2 plus 3 dy by dx is equal to cos x, or 3 dy by dx is equal to transfer plus 2 to the right hand side. This becomes cos x minus 2. Only dy by dx is equal to cos x minus 2 divided by 3 is the derivative of this function. Okay, this is very easiest problem for 2 marks. Hope you are following. It's very simple problem. Just differentiate it on both sides and equate the terms containing dy by dx on one side. Divide, you will get the answer. That's it. Now let us come to the next problem. Similar type problem. What is the problem given? Dy by dx. Find dy by dx if 2x plus 3y is equal to sin y. In the previous problem, it is sin x. Here it is sin y. Let me take. Now given equation is 2x plus 3y is equal to sin y. Same, differentiating with respect to x on both sides. If you differentiate this, 2 into differentiation of x is 1, 3 into differentiation of y is dy by dx is equal to, this is, call it as sin x, derivative of sin x is cos x, right? So this is d by dx of sin x is equal to plus cos y into dy by dx. This is cos y into dy by dx. Now, just transfer this 3 dy by dx and transfer this plus cos to the left hand side. Cos of dy by dx is equal to transfer plus 2 to the right hand side. It becomes minus. Now you can remove the common factor. Dy by dx out. You can write it as 3 minus cos y is equal to minus 2. Therefore, dy by dx is equal to minus 2 divided by 3 minus cos y. This is the simplified answer. Otherwise, if you want, you just keep 2 here and transfer this, or you can also write like this, or 2 is equal to cos y into dy by dx minus 3 times dy by dx. So this is 2 is equal to cos y minus 3 into dy by dx, or only dy by dx is equal to 2 divided by cos y minus 3. Anything same, just the negatives you will get, that's it. So this is the required answer. Listen to me. So what is given? 2x plus 3y is equal to sin y. Differentiating with respect to x on both sides. 2 into differentiation of x is 1. 3 into differentiation of y is dy by dx. And derivative of sin y is cos y. And derivative of y is dy by dx. We are differentiating y with respect to x. So therefore this is function of a function cos y into dy by dx. Now just transfer this 3 dy by dx minus cos y dy by dx is equal to minus 2. Or if you remove 2 dy by dx as common factor, dy by dx out, 3 minus cos y is equal to minus 2. dy by dx is equal to minus 2 divided by 3 minus cos y is the answer. Otherwise, at this stage if you want, you can transfer this to the right hand side. So 2 is equal to cos y dy by dx minus 3 dy by dx. dy by dx is the common factor. Then dy by dx is equal to 2 times cos y minus 3. Any answer you can write, no problem. One and the same. Now let's come to the next problem. Similar type problem. Find dy by dx if ax plus by square is equal to cos y. Same type problem. What is given? Ax plus b into y square is equal to cos y. Differentiate it. Differentiating with respect to x on both sides. If you differentiate a constant, differentiation of x is 1 plus b into derivative of y square is 2y into dy by dx. Because we are differentiating y with respect to x. So differentiation of y square is 2y into dy by dx. This is equal to, again differentiation of cos y is minus sin y into dy by dx. Function of a function again. See here, a into differentiation of x is 1 plus b into differentiation of y square with respect to x. Differentiation of y is 2y dy by dx, and differentiation of cos y is minus sin y into dy by dx. Now just bring this to the right hand side or transfer this. A is equal to minus sin y into dy by dx, and this becomes minus 2by dy by dx. You can remove the common factor. Dy by dx is the common factor. What you will get? Minus sin y minus 2by. Therefore dy by dx can be written as a divided by minus a divided by, just take minus common factor. Otherwise I will write a is equal to, this is minus of sin y plus 2by into dy by dx. So therefore dy by dx is equal to minus a divided by sin of y plus 2 into by. This is the required answer. That's it. Otherwise you can transfer here itself. You can transfer this and transfer minus plus a to right hand side, you will get the same answer, no problem. So what is given? Ax plus by square is equal to cos y. Differentiating with respect to x on both sides. A into differentiation of x is 1 plus b into differentiation of y square is 2y dy by dx. Because we are differentiating y with respect to x, it's a function of a function. Again into dy by dx. Again this is also a function of a function. Derivative of cos x is minus sin x. It is y. Derivative of cos y is minus sin y into dy by dx. So just transfer this b to y to right hand side. Then minus sin y dy by dx minus b into 2y is 2by dy by dx. Dy by dx common factor. This is minus sin y into 2by, or you can remove minus out, minus into sin y plus 2by dy by dx, or only dy by dx is equal to minus a divided by sin y plus 2b into y is the derivative of the function. Followed. Now let us come to the next problem. Now same type problem. What is the problem given? Find dy by dx if xy plus y square is equal to tan x plus y. This is the given condition. What is given? X into y plus y square is equal to tan x plus y. Now differentiating with respect to x. Differentiate with respect to x on both sides. what you will get, see here, this is two variables x and y. So this can be differentiated using product rule. uv, first function, into differentiation of second function is dy by dx plus y into differentiation of x is 1. This is very important step. First function into differentiation of y is dy by dx plus y into differentiation of x is 1 plus here derivative of y square is 2y into dy by dx. We are differentiating with respect to x. Again, differentiation of tan x is as usual secant square x. Again, differentiation of y is dy by dx. That's it. See here, this is xy, d by dx of xy is product rule. First function into derivative of second function is dy by dx plus y into derivative of x is 1. First function into differentiation of second function plus second function into differentiation of first function plus derivative of y square is 2y dy by dx and differentiation of tan x is secant square x and differentiation of y is dy by dx. Now equate the terms which contains dy by dx on one side. So x into dy by dx plus 2y dy by dx and transfer this plus dy by dx becomes minus dy by dx. And what is left over in the right hand side is secant square x and transfer plus y to right hand side, this becomes minus y. See here, this is here itself x dy by dx, again 2y dy by dx and transfer plus dy by dx becomes minus dy by dx, secant square x and transfer this plus y to right hand side, it becomes minus y. Now you can remove the common factor dy by dx out. What is remaining? X plus 2y minus 1 is equal to secant square x minus y. So therefore only dy by dx is equal to, in the right hand side what we will have, secant square x minus y divided by in the denominator x plus 2y minus 1. This is the required answer. So what is the required answer? Secant square x minus y divided by x plus 2y minus 1 is the required answer. Very simple problem. This is 3-mark question. So what is given? xy plus y square is equal to tan x plus y, differentiating with respect to x on both sides. This is product rule. u into v, first function into derivative of y is dy by dx plus y into differentiation of x is 1. Again differentiation of y square is 2y dy by dx is equal to differentiation of tan x is secant square x and derivative of y is dy by dx. We are differentiating with respect to x. Now therefore group the terms which contains dy by dx on one side. So x dy by dx plus 2y dy by dx and transfer this dy by dx to left hand side, it becomes minus dy by dx and keep this secant square x itself here and transfer this plus y to right hand side, it becomes minus y. You can remove dy by dx common factor, x plus 2y minus 1 is equal to secant square x minus y. So therefore only dy by dx is equal to, bring this to the denominator, secant square x minus y divided by x plus y minus 1 is the derivative of this function. This is very important and very easy. These are all very easiest type of problems. Now let us come to the next type problem. Now find dy by dx if x square plus xy plus y square is equal to 100. This is also a very important problem. So you may expect this type of questions for 2 mark. So very simple. What is given? X square plus xy plus y square is equal to 100. Now differentiating with respect to x on both sides. Now what is given? X square plus xy plus y square is equal to 100. Differentiating with respect to x on both sides. Term by term division. I'll put full steps. D by dx of x square plus d by dx of xy plus d by dx of y square is equal to d by dx of 100. Okay, now here differentiation of x square is 2x plus, here see, like previous problem, UV method. First function x into differentiation of y is dy by dx plus second function y into differentiation of x is 1 plus here again it is differentiating y square with respect to x. Differentiation of y square is 2y into dy by dx and derivative of a constant 100 is 0. See, this is very important step. Differentiation of x square is 2x and we are differentiating with respect to x. There are two variables x and y. Let us call it as first function and second function, UV product rule. First function x into differentiation of y is dy by dx plus second function y constant, differentiation of x is 1. Again derivative of y square is 2y into dy by dx. is equal to, on the right hand side, derivative of 100 constant is 0. Now equate the terms containing dy by dx. You just keep this to here itself. What is left? X into dy by dx plus 2y dy by dx, 2y dy by dx, and transfer plus 2x to right hand side. This becomes minus 2x, and plus y, it becomes minus y. Now you can remove the common factor. We can remove dy by dx out. X plus 2y. You can remove minus out. Then this is 2x plus y. Dy by dx can be written as minus of 2x plus y divided by x plus 2y. Don't get cancelled. Don't cancel this because it won't get cancelled. This is 2x and this is 2y. Okay. So the derivative of this function is dy by dx is equal to minus of 2x plus y divided by x plus 2y. Listen to me. This is very important for 2 marks. Very important problem. X square plus xy plus y square is equal to 100. Differentiating with respect to x on both sides, what we will get? D by dx of x square plus d by dx of xy plus d by dx of y square is equal to d by dx of 100. Now differentiation of x square is 2x. This is uv, two variables. Function of these are, you can apply product rule for this. uv, first function into derivative of second function is dy by dx plus second function into derivative of first function x is 1. Whereas this is again function of function. Derivative of y square is 2y dy by dx, and 100 is a constant. Derivative of a constant is 0. Now just keep dy by dx term here itself. X dy by dx plus 2y by dy by dx, and transfer the remaining terms to right hand side. Plus 2x becomes minus 2x and plus y becomes minus 1. So you can remove dy by dx common factor. Dy by dx out, x plus 2y is equal to, again you can remove minus common factor, minus of 2x plus y. Therefore dy by dx is equal to minus 2x plus y divided by x plus 2y is the required answer. This is the required answer for this problem. Now let us come to the similar type problem. Now same type problem, cubic term. What is given? Find dy by dx if x cube plus x square y plus xy square plus y cube is equal to 81. Now differentiate this. What is given? X cube plus x square y plus xy square plus y cube is equal to 81. Now differentiating with respect to x on both sides. Now what is differentiation of x cube? 3x square. Again this is product rule, right? First function and second function. X square constant, differentiation of y is dy by dx plus y constant, differentiation of x square is 2x. Again this is also product rule. See, x first function, differentiation of y square is 2y dy by dx plus second function y square constant, differentiation of x is 1. Again plus this is again differentiation of y cube is 3y square dy by dx is equal to 81 constant, derivative of a constant is 0. Very important step. See here, x cube derivation, derivative of x cube, d by dx of x cube is 3x square, and x to the power of n minus 1, 3x square. Again this is two variables, x and y. Product rule you can apply. X square into dy by dx plus y into differentiation of x square is 2x. Again this is also product rule. X first function and differentiation of y square is 2y dy by dx plus y square second function and differentiation of x is 1. Differentiation of y cube is 3y square dy by dx. Now equate the terms containing dy by dx on one side. What are the terms? This is x square dy by dx plus 2xy dy by dx plus 3y square dy by dx, and transfer the remaining side terms to right hand side. Plus 3x square becomes minus 3x square, and again this is 2xy minus 2xy, and plus y square becomes minus y square. Here you can remove the common factor, dy by dx out. What is left over? X square plus 2xy plus 3y square is equal to, you can remove minus out, minus 3x square plus 2xy plus y square. Now so therefore dy by dx, the required answer dy by dx is equal to this minus of 3x square, put it in order, plus y square plus 2xy whole divided by this denominator x square plus 3y square plus 2xy. This is the required answer. So just equate the terms containing dy by dx on one side, remaining term transfer to the right hand side. So dy by dx is equal to this divided by this. Dy by dx is equal to minus 3x square plus y square plus 2xy divided by x square plus 3y square plus 2xy is the required answer. Very important for 3 marks. Now let us come to the next problem. Find dy by dx if sin square y plus cos of xy is equal to k. See here again, this is function of two variable x and y. Again we are going to apply product rule for that. Now what is given? Sin square y plus cos of xy is equal to k. Now differentiating with respect to x. So this is n is 2, f of x to the power of n, 2 sin y, right, into d by dx of sin y is cos y into dy by dx. Listen to me. This is f of x to the power of n. N is 2. 2 sin y into d by dx of sin y is cos y dy by dx. Plus, because if you want, I will write here, see. If it is like this, d by dx of sin square x means, what we are going to write? 2 sin x into d by dx of sin x. So this is 2 sin x into differentiation of sin x is cos x. If it is sin square x, this is sin square y. What is n here? N is 2 sin y into d by dx of sin y is cos y into y with respect to x is dy by dx. Again, this is x. Differentiation of cos x is minus sin xy into d by dx of xy is equal to derivative of a constant is 0. See here, 2 sin y cos y dy by dx. Again this is cos xy. Differentiation of cos xy is minus sin xy minus of sin xy into d by dx of xy is equal to 0. So this is 2 sin y cos y dy by dx minus sin of xy as it is. If we differentiate this, we are going to apply again product rule for this. So that is first function x into differentiation of y is dy by dx plus y into differentiation of x is 1 is equal to 0. So this is of the form 2 sin theta cos theta. You can write this as sin 2 theta sin 2a. What is sin 2a? 2 sin a cos a. This can also be written as sin 2y dy by dx. Now multiply by sin of xy. So if you multiply by sin of xy, you will get x sin xy dy by dx minus into plus minus y into sin xy is equal to 0. Now equate the terms which contains dy by dx. These are the two terms. So in these two terms, dy by dx is the common factor. So if dy by dx is taken out, what you will get? Sin 2y minus dy by dx is out. What is left over is x sin xy is equal to, transfer this to the right hand side, this is equal to y into, minus becomes plus y sin xy. Followed? See here, very simple. Here dy by dx common factor, sin 2y minus x sin xy, and transfer minus y to right hand side plus y sin xy. So therefore the required answer only dy by dx is equal to y into sin of xy divided by sin of 2y minus x into sin of xy. This is the required answer. So sin of 2y minus x into sin of xy in the denominator, and in the numerator y sin xy. Listen to me, I will explain once again. What is given? Sin square y plus cos xy is equal to k. Differentiating with respect to x on both sides. 2 into, this is f of x to the power of n. So like this, differentiation of sin square x can be written as n is 2 sin x, 2 minus 1 is 1, 2 sin x into d by dx of sin x is cos x. This can also be written as, this is also equal to sin 2x, right? What is sin 2x? 2 sin x cos x. Same type, 2 sin y into differentiation of sin y is cos y dy by dx and this is cos. Derivative of cos is minus sin xy into d by dx of xy is equal to k constant 0. Now 2 sin y cos y as it is. Again this is minus into plus minus sin xy. You can apply the product rule for this because there are two variables x and y. So first function into differentiation of y is dy by dx plus y into differentiation of x is 1. This is 0. Now 2 sin y cos y can also be written as sin 2y. Multiple angle of a. Sin 2a is 2 sin a cos a. Sin 2y is 2 sin y cos y. Minus multiply by this. Sin xy, x into minus sin xy dy by dx, minus into plus it is minus y sin xy. Just equate the terms which contains dy by dx, that is sin 2y dy by dx minus x sin xy dy by dx is equal to y sin xy. Dy by dx is common factor. So what you will get, sin 2y minus x sin xy is equal to y into sin xy. Therefore, dy by dx is equal to y into sin xy divided by sin of 2y minus x into y. This is the required answer for this. This is very important problem indeed for 3 marks. Followed. Let's come to the next problem. This is the next problem. What is the next problem? Find dy by dx if sin square x plus cos square y. This is one is x, another one is y. So what is given? Given sin square x plus cos square y is equal to 1. Now differentiate it. Differentiating with respect to x on both sides. So differentiation of this is f of x to the power of n, again f of x to the power of n as we did in the previous problem. Here n is 2. 2 sin to the power of 2 minus 1 is 1 into d by dx of sin x is cos x. Plus here it is same 2 into cos y. Differentiation of cos y is minus sin y into derivative of y is dy by dx is equal to 0. See the difference here. This is x square, this is sin square x. So therefore differentiation of sin square is 2 sin x cos x. Whereas this is cos square y, 2 cos y sin y into dy by dx along with negative sign. Now this can be written as 2 sin x cos x can be written as sin 2x, and this is plus into minus minus. 2 sin y cos y can also be written as sin 2y into dy by dx is equal to 0. Transfer this. Sin 2x is equal to sin of 2y dy by dx. Therefore, only dy by dx is equal to, bring this to the denominator, sin 2x divided by sin 2y. This is the required answer. You cannot write it as tan because it is 2x, in the denominator it is 2y. Okay. Otherwise you can also solve like this. Here. So R this is here, this is the step, that is from this I can write 2 sin x into cos x minus 2 sin y cos y dy by dx is equal to 0. So transfer this, what we will get? So this is 2 sin x into cos x is equal to 2 sin y cos y dy by dx. So only dy by dx is equal to 2 sin x cos x divided by 2 sin y into cos y. 2 and 2 gets cancelled. You can write sin x into cos x divided by sin y into cos y. Okay, this is the required answer. This is, you can write this or that. Sin 2x divided by sin 2y is nothing but 2 sin x cos x, 2 sin y cos y, 2 gets cancelled. You will get the same step. Sin x cos x divided by sin y cos y. Okay, this is the answer. See here, differentiating with respect to x on both sides. This is sin square 2 sin x into d by dx of sin x is cos x. 2 cos y into d by dx of cos y is minus sin y into dy by dx is equal to 0. So 2 sin x cos x is sin 2x, 2 sin y cos y is equal to sin 2y. Transfer this. Sin 2x is equal to sin 2y dy by dx, or dy by dx is equal to sin 2x divided by sin 2y or sin x cos x divided by sin y cos y. Now let us come to the next problem. X square plus y square plus 2xy plus x plus y plus 3 is equal to 0. Find dy by dx at 1 comma minus 1. As usual, differentiate with respect to x on both sides. Then get the value of dy by dx. At the end, put x is equal to 1 and y is equal to minus 1. That's it. Now differentiating with respect to x. So this is differentiation of x square is 2x. Differentiation of y square is 2y dy by dx. Again, this is two constant. Product rule. See here, first function and second function. X into differentiation of y is dy by dx plus y into differentiation of x is 1 plus differentiation of x is 1 plus differentiation of y is dy by dx. On the right hand side, derivative of 0 plus 3 is also 0. Now this is 2x plus 2y dy by dx plus multiply by 2, 2x dy by dx plus 2y into 1 is 2x into y. 2y into 1 is 2y plus 1 plus dy by dx is equal to 0. Check. Differentiation of x square is 2x, y square 2y dy by dx. This is UV method. Two constant. First function x into differentiation of y is dy by dx plus y constant. Differentiation of x is 1 plus derivative of x is 1 plus derivative of y is dy by dx. 3 constant, 0 is equal to 0. Now multiply by 2. 2 into x is 2x dy by dx. 2 into 1 is 2y plus 1 plus dy by dx. Now equate the terms containing dy by dx. So what are the terms? 2x dy by dx plus 2y dy by dx plus this dy by dx is equal to, transfer this, plus 2x becomes minus 2x and plus 2y becomes minus 2y and plus y plus 1 is minus 1. So here you can write dy by dx as 2x plus 2y plus 1. Here you can remove minus 2x plus 2y plus 1. So therefore dy by dx is equal to minus of 2x plus 2y plus 1 whole divided by denominator is also same, 2x plus 2y plus 1. What happens? Dy by dx is equal to minus 1. These two gets cancelled. You will get minus 1. So there is no need to substitute the value of x and y. It gets cancelled. You will get a constant minus 1. Dy by dx is equal to minus 1. So the derivative of this function is minus 1. That's it. This is how we are going to differentiate these implicit functions. Followed? Hope you understood this. So this type of problems are very, very important for the point of examination. Definitely you will get at least one question either for 2 marks or for 3 marks. Okay. Now that's all regarding today's session. We'll meet again in the next session with the different concepts. Thank you very much. Thank you.